Hello and welcome back. We're now going to go over section 5.5 where we learn how to graph functions of the form y equals a times sine bx plus c and y equals a times cosine bx plus c. And a, b, and c are all just going to be normal numbers, not variables. The only variable here is x. Okay, so that's our objective for today. We're going to need a few pieces first. The first of which is we're going to need to know what the amplitude of a sine or cosine graph is. And quite simply, it's just the height of the wave. So if we look here at, let's say, y equals cosine x versus y equals 2 cosine x, in black we have the graph of cosine x. So we saw that at the end of the last video. And here's the graph of 2 cosine x. So you see that its wave is 2 units high from its sort of center line. Whereas the cosine, there's technically a 1 in front of there. The height of its wave is just 1. And so to find the amplitude, you just take the absolute value of the number multiplying in front of either sine or cosine. Okay. So here, like in this example, we have y equals sine x. Again, we've seen this before. This is our normal sine graph. Y equals minus 1/2 sine x. Well, the minus is going to flip it upside down. That much we know about negatives out front. But the amplitude is still 1/2. Okay, it's the absolute value of negative 1/2. And so when we graph it, we flip the graph upside down, and then everything gets halved. So it looks instead looks like this. And of course, these graphs go off in either direction indefinitely. Their domain is all real numbers. Okay, the next piece of information is the period of a graph. So we talked about this last time. If you have just normal cosine x, let's say, the period we know is 2 pi. That much we saw. But what happens if there's a number multiplying the variable x, okay? So nothing too exciting going on in this first example, but here y equals sine of 2x. It turns out that the period is going to be pi, and here's how you find that. You always take 2 pi and divide by the absolute value of the number multiplying x. So here I'm going to take 2 pi divided by the absolute value of 2. The absolute value of 2 is just itself, so I get 2 pi over 2, which of course reduces to pi. And so here's what that looks like. If you multiply the x value by a number bigger than 1, it's actually, so in this case 2, it's actually going to speed up how quickly the graph of sine or cosine repeats itself, because the period then gets smaller. So you see here we only have a period of pi for this graph. And we see that now, I mean, look at the graph of sine versus the graph of sine of 2x, right? So sine of x, it achieves a value of 1 at pi over 2, whereas at pi over 4, sine of 2x achieves a value of 1. And the reason for that is, well, let's see. So here we just get sine of 2 times 0, which is sine of 0, so that's 0. But here we get sine of 2 times pi over 4, when I plug in pi over 4, right? And that's sine of pi over 2, reduce the fraction. But that's 1, right? So it reached 1 faster. It reached it at, in fact, twice as fast, right? Instead of reaching it at pi over 2, like normal sine, it reached it at pi over 4. And I'll just quickly fill in the rest of this table here. But like when I plug in pi over 2 into sine of 2x, I just get sine of pi, which is back to 0, right? So that's why we have an output of 0 here. Sine of 2 times 3 pi over 4. Reduce a factor of 2, and you get sine of 3 pi over 2, which we know is negative 1, and that's why the value is down here. So see your table or see your unit circle. That's how you'll find these values quickly. And then sine of pi, well, or excuse me, plug in pi into sine of 2x, I get sine of 2 pi, which I know is 0. So find that on your unit circle or your table. But the value is 0. Okay, so the larger the number multiplying x, the smaller the period will be. Okay, the more quickly it runs through its values. And here's how you find it with this formula here: 2 pi divided by absolute value b. Okay, the next thing we're going to need is something called the increment, and it's very simple. Once you have the period, just divide it by 4. So here, the cosine x, the period was 2 pi. The increment is then 2 pi over 4, and then reduce that fraction. That's just pi over 2. Sine of 2x we just found. The period is pi, so the increment is pi over 4, right? Just divide that answer by 4. Sine of minus 4x, let's say, the period, well, you take 2 pi divided by negative 4 in absolute values, and the absolute value just turns that into a positive 4, so you get 2 pi over 4, and then reduce the fraction to get pi over 2. So the period is pi over 2, which makes the increment pi over 2 over 4. Now it's tempting to try to cancel this 2 and the 4, but actually what you get is pi over 8. And the reason for that is, if you like, you can think of 4 as the fraction 4 over 1, and now everyone knows to flip and multiply, and so you see you actually get the 4 times 2 on the bottom, and that's what gives you the 8 there. Okay, so that's a common mistake I see, is dividing a fraction by 4 and somehow like the 2 and the 4 will cancel, but that's not really what happens. All right, the last piece of information we'll need before we get to graphing is something called the phase shift, and this is essentially the horizontal translation of the graph. So it has something to do with this c value here. So the way that you find the phase shift, it's given by minus c over b. And so let's look here. If y equals cos 2x plus pi, the phase shift is minus the c value, which is pi. Notice it's a plus pi. And then divide by the number in front of x, which is 2. And notice I don't do the absolute value, right? I just take the numbers as I see them. So I take the negative of the number, the constant term, divided by the number in front of x. So here, phase shift of 5 sine minus 3x minus 9. It's the negative of this number, so negative 9, divided by the number in front of x, so divide by negative 3. And you see a double negative on top, so you get 9 over negative 3, which reduces to negative 3. Okay. All right, so now let's actually get into the graphing. So this first one, I'm doing most of these details for you since they're pretty straightforward. The amplitude is just the absolute value of this number, so that's just 3. The period is 2 pi divided by the absolute value of that number, so 2 pi over 2 is just pi. The increment, just take this answer, divide by 4, that's easy. And now the phase shift is negative this number, so negative minus pi over 2, divided by exactly this number, so divided by 2. And so the negative cancels. Now I get pi over 2 over 2. The 2's do not cancel. This is pi over 4. Okay. All right, so here is how we make the graph now. So we are going to make a table of values, and there's going to be 5 values in the x column. We're going to start with the phase shift, so pi over 4. And then to get the next x value, we're going to add to it the increment. So I start with pi over 4. My next x value is this number plus pi over 4, which is pi over 2. Then my next x value is pi over 2 plus my increment, so 3 pi over 4. Then take this number and add the increment pi over 4 to it, you get pi. And then take this number, add the increment to it, you get 5 pi over 4. Okay. I have 1, 2, 3, 4, 5 numbers in the column. I stop here. Okay. And now just plug all of these in to the function. So here I get 3 times cosine 2 times my x value, which is pi over 4 minus pi over 2. 2 times pi over 4 is pi over 2. And pi over 2 minus pi over 2 is 0. Cosine of 0, be very careful, is 1. So this is 3. Right? 3 times 1, which is 3. Okay, next one. And I encourage you to pause the video and work ahead on this if you like. So I plug in my x value of pi over 2. So 2 times pi over 2 is pi. So I get 3 cos pi minus pi over 2. And then pi minus pi over 2 is pi over 2. And cosine of pi over 2, look on your chart or your unit circle, that's 0. So I just get 0. Okay. So I'll skip ahead for these next ones. Okay, so what we have here is when we reduce this one, we get 3 times the cosine of pi. Cosine of pi is -1, so you get 3 times -1 is -3. Cosine 3 pi over 2 is 0, so 3 times that is 0. And then, oh look, we've made it all the way back around, right? So inside the parentheses here, you actually get 2 pi, and 3 times cos 2 pi is just 3. Okay, so now we're going to sketch the function. So we have the x values here lined up. And now let's just find the y values. So here's 3, 0 at pi over 2, output of -3 over here at 3 pi over 4, then 0 again, and then 3 again. And what I'd like you to do, don't make it a V, make it a nice smooth curve, and then just kind of go like that. Okay, and that's all I need you to graph, is just graph one full period of, in this case, the cosine function. As we will see here, in the next example, we're just going to graph one full period of this sine function, minus sine 3x plus pi. All right. So let's fill in the pertinent details here. Amplitude is the absolute value of the number in front of sine. So absolute value of -1 is just 1. The period is 2 pi divided by the absolute value of this number multiplying x. So I get 2 pi over 3. The increment is 2 pi over 3 over 4, which is actually 2 pi over 12, which reduces to pi over 6. Okay. And now the phase shift is negative this number, which is pi, divided by exactly this number, which is 3. So I get minus pi over 3. Okay. And now here's how we fill in the table here. So down the x column, I start with the phase shift, minus pi over 3, and now add this increment successively to get the next 4 values. So minus pi over 3 plus pi over 6 is minus pi over 6. Now to get the next one, I take this, minus pi over 6, and add it to the increment. Minus pi over 6 plus pi over 6 is 0. Then another pi over 6. And then pi over 3. Right? I'll take pi over 6 and add to it pi over 6, which gives me 2 pi over 6, also known as pi over 3. All right. And so I'll do this first one with you, and then I'll hope you'll sort of fast forward to get through the rest of it. But what we see here is we get, plugging in minus pi over 3 for x, I get minus sine 3 times minus pi over 3 plus pi. This is negative sine minus pi plus pi. So you'll see I get 0 in here. Well, that's sine of 0 is 0. The negative doesn't change that. Okay. For this one here, I get negative sine 3 pi over 2, so negative negative 1, which is just 1. And then here I get minus sine 3, plug in pi over 3. This is pi plus pi is 2 pi. And sine of 2 pi is, of course, 0. The negative doesn't change that. And so the graph that I get, well, first let's fill in the x values. Minus pi over 6, 0, pi over 6, and pi over 3. And now let's fill in the y values. So I get a 0, I get a negative 1 at minus pi over 6, I get a 0 here, I get 1 up here, and I get 0 at pi over 3. And now, again, make it a nice smooth graph, no sharp edges, or at least as best you can. And then just kind of give it some dot dots. And that's one full cycle of the sine graph, right? Okay, so hopefully this helps for the worksheet. You should have all you need now to do worksheets 15 and 16 for Friday.